Have you ever wondered what an ocean on another planet might look like? Now imagine one made of lava. Sounds unbelievable, right? But astronomers have just made an extraordinary discovery, a planet with an ocean of molten lava which defies everything we thought we knew about distant worlds. This planet, named K2-141b, is a rock and lava world that sits 300 light-years away in the constellation Leo. It's so alien, so extreme, that it challenges our very concept of what a planet can be like. The surface of this exoplanet is bathed in intense heat, with temperatures soaring over 2,000 degrees Celsius. It's so hot that everything, rocks, metals, even elements that we take for granted, turns to liquid, creating massive seas of molten lava. Imagine this. Vast lakes, oceans, and rivers of lava spread across the planet, their surfaces shimmering under the ever-present heat. In fact, this is the first time we've observed solid evidence of a lava ocean existing on a planet outside of our own solar system. K2-141b is unlike anything we've seen before. It exists in a part of space where extreme conditions create a landscape that seems more like a living nightmare than something from the natural world. Its surface is constantly in a state of flux, with giant rivers of molten lava flowing and shifting in response to the planet's movements. And the temperature. It's so hot that it could melt rock, something we wouldn't even think possible in most places on Earth. But this is what makes K2-141b unique. It doesn't just have molten lava in small quantities, like lava flows, from volcanoes here on Earth. The entire surface of the planet is covered by vast glowing oceans of lava, their surfaces bubbling and churning like the violent seas of an alien world. The existence of K2-141b was first noted by astronomers using NASA's Kepler Space Telescope, a tool designed to hunt for distant exoplanets. But this discovery went beyond the usual findings of rocky planets or gas giants. K2-141b wasn't just another planet, it was scorching, with conditions so extreme that we almost couldn't believe it existed. What astronomers found was a planet that had an intense, constant exposure to radiation from its nearby star. The planet is so close to its star that it orbits it in just 1.5 Earth days, an incredibly short year. In fact, K2-141b completes a full orbit around its star, faster than most of the planets in our solar system complete a single day. This means that the planet is continuously exposed to the brutal, unrelenting heat from its star. This proximity to the star is one of the primary reasons for the extreme temperatures. K2-141b's surface is bathed in heat levels that far exceed what we could even imagine on Earth. With temperatures reaching more than 2,000 degrees Celsius, it's far hotter than the surface of any volcano on Earth. The heat is so intense that it causes the planet's surface to melt, turning rocks and metals into liquid. This molten landscape is vast, stretching across the entire planet, creating massive oceans of lava that define the planet's surface. These oceans are constantly shifting and flowing, just like Earth's oceans. But instead of water, they are made of glowing liquid rock. But it doesn't stop there. K2-141b is tidally locked to its star, meaning that one side of the planet always faces the star, while the other side is in permanent darkness. This phenomenon creates an extreme temperature difference between the day and night sides of the planet. On the day side, where the planet is always exposed to the star, temperatures soar to more than 2,000 degrees Celsius. The lava oceans are constantly heated, and volcanic activity is widespread, contributing to the churning seas of molten rock. On the dark side, however, the temperatures are far cooler. Without the warmth of the star, the surface cools and solidifies, creating a solid, rocky crust that contrasts sharply with the blistering heat on the opposite side. This temperature contrast between the day and night sides of the planet is one of the most fascinating features of K2-141b. As the planet rotates, the molten lava seas are continuously pushed between the two extremes, shifting from the intense heat of the day side to the freezing cold of the night side. The boundary between the two sides, the terminator line, is constantly in flux, with the molten lava reaching towards the solidified crust, creating an ever-changing landscape. On the day side, the lava is constantly in motion, flowing like rivers and crashing into the rocky landmasses. On the night side, the solidified surface could crack and break apart as the lava from the day side slowly cools and solidifies. Now, imagine walking on the surface of this planet, if it were even remotely possible. The ground beneath your feet would be a mixture of boiling lava and solid rock. The air would be thick with toxic gases like carbon dioxide, sulfur, and other chemicals that are constantly being released by the volcanic activity. You would be surrounded by a fiery glow from the lava oceans, with a sky filled with dark, swirling clouds of vaporized metals and sulfuric compounds. The atmosphere would be dense, almost choking, making it impossible for humans to survive, let alone explore the planet in person. And yet, this alien world with its molten seas and volcanic chaos continues to captivate astronomers and scientists who are eager to learn more about this extreme environment. What makes K2-141b even more fascinating is the way it challenges our understanding of how planets form and evolve. It's one thing to imagine a planet with extreme heat or volcanic activity, but it's another to find one that has an entire ocean of lava, an environment that we never thought could exist on such a massive scale. The discovery of K2-141b is forcing scientists to reconsider the types of planets that could exist in the universe. Could there be more planets like K2-141b out there? Planets with molten oceans instead of water, where life could survive in ways we never imagined? As scientists continue to study K2-141b, they are learning more about how planets are shaped by their proximity to stars, how atmospheres evolve in extreme conditions, and how volcanic activity can shape a planet's surface. The study of K2-141b offers a unique opportunity to learn about planetary geology, extreme climates, and even the potential for life in places we never thought to look. Are you beginning to wonder just how many more strange and extreme planets are out there, hidden in the far corners of the universe? Could there be more molten worlds like K2-141b waiting for us to uncover their secrets? The discovery of this lava ocean planet is just the beginning of an exciting journey into the unknown. Stay with us, because there's so much more to explore. As we dive deeper into the mysteries of K2-141b, it becomes clear that this planet isn't just a unique anomaly in the universe. It's a window into how extreme conditions might shape not just planets, but possibly the way life could evolve under unimaginable circumstances. Let's start with the extreme atmospheric conditions on K2-141b. Scientists believe that this world could hold the key to understanding how planets evolve in intense environments. The atmosphere on K2-141b is incredibly thick, composed of dense layers of gases like carbon dioxide and water vapor, both of which are expelled by its constant volcanic activity. But the most interesting aspect of this atmosphere is how it interacts with the planet's molten surface. The constant volcanic eruptions release vast amounts of sulfur dioxide. This gas combines with water vapor to form sulfuric acid clouds, similar to the ones that make Venus's atmosphere so dangerous. These clouds are constantly shifting, swirling above the lava oceans, their toxic makeup turning the atmosphere into an incredibly hostile environment. Imagine standing on the planet's surface, surrounded by these thick, billowing clouds. The air is so dense and filled with corrosive gases that breathing would be impossible. The sky would be dark and foreboding, lit by the eerie glow of molten lava beneath it. Every breath you take would burn your lungs as if the very air itself was alive with danger. And yet, in this extreme environment, there's something eerily beautiful about it all. The constant storming of the atmosphere, the bright red glow from the lava oceans, and the ever-changing landscape that seems to be alive in its own way. Now consider the concept of volcanic activity. On Earth, we've seen volcanic eruptions create landforms, shape oceans, and release gases into the atmosphere. But on K2-141b, volcanic activity isn't just a secondary event. It's the lifeblood of the planet. The volcanoes on K2-141b are massive, constantly spewing molten rock into the atmosphere, creating layers of volcanic ash and vapor. The lava oceans themselves are continuously replenished by these eruptions, which ensures that the planet's surface is constantly changing. The very landscape of K2-141b could look completely different after just a few days, with massive lava flows shifting the surface and new volcanic islands emerging from the molten seas. This ongoing volcanic activity on K2-141b is something we can only begin to comprehend. Imagine an entire world constantly remaking itself, volcanoes erupting, lava pouring into the seas, and new landforms rising and falling like a planet in perpetual motion. This dynamic process isn't just about the creation of new land. It also means that the planet is constantly releasing heat into the atmosphere. The heat from these eruptions fuels the planet's wild climate, contributing to the extreme weather patterns and dramatic shifts in temperature between day and night. The volcanic activity also plays a crucial role in maintaining the atmosphere. On Earth, volcanic eruptions release gases like carbon dioxide and sulfur, which contribute to the planet's greenhouse effect. But on K2-141b, this process is taken to a whole new level. The intense volcanic outgassing keeps the planet's atmosphere thick and dense, creating a vicious cycle of heat retention. In fact, K2-141b's atmosphere may be so thick that it creates a runaway greenhouse effect, similar to what we see on Venus. This would mean that the planet's surface temperature is essentially locked in place by the thick, insulative layer of gases, making it impossible for the planet to cool down. As we peer deeper into K2-141b's unique climate system, we also have to consider the possibility that its molten seas could have a profound effect on its atmosphere. Just like the lava oceans on Earth create intense steam when they come into contact with water, the lava oceans of K2-141b likely produce vast amounts of vaporized rock and minerals that get trapped in the atmosphere. This creates a feedback loop, where the atmosphere and the surface are in constant interaction, constantly exchanging energy in the form of heat, gases, and volcanic emissions. The result is a planet where the surface and atmosphere are so intertwined that it's hard to separate the two. But what about the night side of K2-141b? As we mentioned earlier, K2-141b is tidally locked to its star, meaning that one side of the planet is always facing the star, while the other remains in eternal darkness. This creates a stark contrast between the two sides, an inferno on one side and a frozen wasteland on the other. On the day side, the molten lava oceans churn and bubble under the constant heat, while on the night side, the temperature plummets to several hundred degrees below zero. Without the heat from the star, the lava oceans freeze into solid rock, creating a barren frozen wasteland. But even this frozen side of K2-141b may not be as desolate as it seems. The extreme temperature contrast between the day and night sides could create some unusual atmospheric phenomena. For example, winds could form as the hot air from the day side rises and the cold air from the night side sinks. These winds would likely be incredibly powerful, moving at high speeds across the planet's surface, creating dust storms and intense weather patterns. Imagine the violent storms that could form in the twilight zone, the boundary between the molten seas and the frozen wasteland. Here the forces of extreme heat and cold would clash, creating violent storms that rage across the planet's surface. This extreme contrast between the two sides of K2-141b could also affect how its volcanic activity operates. Volcanoes on the day side may be constantly active, spewing lava and gases into the atmosphere, while on the night side the cooling of the lava seas may create a solid crust that periodically cracks, releasing massive amounts of gas and heat. This could lead to explosive volcanic events, where large portions of the night side's frozen surface shatter, sending plumes of volcanic ash and steam into the atmosphere. These dynamic processes happening on K2-141b don't just make it a fascinating object of study for scientists. They could also hold valuable clues for understanding other, more distant worlds. How do planets like K2-141b form in such extreme environments? How do their atmospheres evolve over time? Could there be any possibility for life to exist in these extreme conditions? While we don't have the answers yet, the discovery of K2-141b opens up a whole new chapter in our understanding of exoplanets, one where extreme environments create new possibilities for the nature of life and the evolution of worlds. K2-141b is more than just an oddity in the vast universe. It's a laboratory in the sky, offering us a glimpse into the future of planetary science. And the more we learn about it, the more we realize that this is just the beginning. The mysteries of molten oceans, volcanic activity, and extreme climates are waiting for us to uncover them. K2-141b might be far from home, but its secrets are closer than we think. Now that we've explored the extreme atmospheric and volcanic conditions on K2-141b, let's zoom out and consider what makes this planet so significant, not just for science but for the broader search for life in the universe. The discovery of K2-141b forces us to question everything we thought we knew about habitable environments, planetary formation, and even the possibility of life beyond Earth. At first glance, a planet covered in molten lava and an atmosphere thick with toxic gases might seem like the last place where life could exist. But that's exactly where this discovery gets interesting. What if, despite the brutal conditions on K2-141b, there could be a form of life that not only survives, but thrives in such a hostile environment? This concept might seem far-fetched, but it's something that scientists are now seriously considering. The study of K2-141b has sparked a fascinating debate about what constitutes a habitable environment. We've long defined habitable zones as the Goldilocks zone, the region around a star where conditions are just right for liquid water to exist, enabling life as we know it. Earth, of course, falls within this zone around our Sun, but K2-141b challenges this traditional view. It's not just the presence of liquid water that supports life, it's the potential for life to adapt to extreme conditions. Could life on K2-141b exist in forms we can't even imagine yet, thriving in the planet's molten oceans and toxic atmosphere? To explore this idea, scientists are looking to Earth's own extreme environments for clues. Deep beneath the ocean, in the dark, crushing depths, there are organisms known as extremophiles that thrive in conditions that would be lethal to most life forms. These organisms survive in temperatures that exceed 100 degrees Celsius, in acidic environments, and in places where there's no sunlight. Some even derive energy not from the sun, but from the chemicals in their environment. If life can thrive in such extreme conditions here on Earth, why couldn't something similar evolve on K2-141b? One of the most fascinating parallels is with the hydrothermal vent ecosystems we've discovered deep in Earth's oceans. These vents spew hot, mineral-rich water from beneath the ocean floor, creating an environment full of life despite the lack of sunlight. These ecosystems are powered not by photosynthesis, but by chemosynthesis, a process where organisms use the energy in chemicals like hydrogen sulfide to produce food. This is exactly the kind of energy source that could potentially exist on K2-141b. If the molten oceans of the planet are rich in minerals, could some form of life evolve to use the energy from these minerals to sustain itself? Another intriguing possibility is the role of K2-141b's volcanic activity in sustaining life. On Earth, volcanoes are not just destructive forces, they are also vital for creating the conditions that life depends on. Volcanic eruptions release important elements like carbon, nitrogen, and sulfur into the atmosphere, which are key ingredients for life. On K2-141b, the constant volcanic activity could play a similar role, providing the chemical building blocks necessary for life to form. This volcanic activity could also contribute to the formation of complex organic molecules, potentially paving the way for some kind of alien biochemistry to take root. However, there are also significant challenges to life on K2-141b. The planet's intense heat would make it difficult for water, as we know it, to exist in liquid form. Any form of liquid water would either evaporate or freeze, leaving little room for life as we understand it. But as we learned from extremophiles on Earth, life doesn't always need liquid water in the way we think. Could life on K2-141b exist in a completely different biochemical form, one that doesn't rely on water? What if life here is based on liquid chemicals that don't evaporate at high temperatures, like molten metals or other exotic substances? It's a concept that scientists are only beginning to explore, but it opens up tantalizing possibilities for how life could evolve in completely alien environments. Even more thought-provoking is the possibility that K2-141b is not a dead planet at all, but one still undergoing the birth of life, something we've never seen before. Imagine a planet in the early stages of biological development, where molten oceans and volcanic eruptions might be the first steps in creating the building blocks of life. The extreme conditions on K2-141b could be creating an environment that is ripe for the formation of complex molecules, perhaps even the precursors to life. The more scientists study this planet, the more they realize that K2-141b could hold a hidden potential, a snapshot of a world in the making, where life might be just on the verge of beginning. But what does this mean for the broader search for life in the universe? The discovery of K2-141b's molten oceans forces us to reconsider the definition of a habitable zone. For years, we've focused on planets that are similar to Earth, those that exist in the so-called Goldilocks zone around their stars. But K2-141b suggests that life could exist in far more extreme conditions than we previously thought. What if life isn't just limited to Earth-like planets with temperate climates? What if the universe is teeming with planets like K2-141b, where life is based on entirely different principles, thriving in conditions that seem hostile to us? The implications of this discovery stretch far beyond just one planet. If life can exist on K2-141b, then there may be countless other planets out there that we've overlooked in our search for extraterrestrial life. The search for life in the universe may not just be about finding Earth-like planets. It's about expanding our understanding of what it means to be habitable and what life could look like in the most extreme environments. K2-141b forces us to ask, what if life exists where we least expect it? Could we find thriving ecosystems on planets that are nothing like Earth, where life is based on chemistry, energy sources, and conditions beyond our wildest dreams? To further complicate the mystery, we know that the planet's star is also unusual. Its radiation levels are high and it's constantly bombarding K2-141b with intense ultraviolet light. This radiation could actually help drive the chemistry needed to form life, acting like a cosmic catalyst that kicks off reactions in the planet's atmosphere. Imagine a place where the energy from a star's radiation and the molten lava oceans combine to create an environment where life can develop in ways we're only beginning to understand. The discovery of K2-141b and its molten oceans is more than just a scientific curiosity. It's a glimpse into the diversity of worlds in our universe. It's an invitation to rethink our approach to finding life in space. The universe may not be filled with planets like Earth, but that doesn't mean it isn't teeming with strange, bizarre worlds, each with its own kind of potential for life. K2-141b is a powerful reminder that the universe's mysteries are endless, and the more we learn, the more we realize just how much there is still to discover. As we wrap up our journey to the heart of K2-141b, it's clear that this planet is not just a curiosity for scientists, it's a window into the unknown. It forces us to reconsider everything we thought we knew about life, planets, and the nature of habitable zones in the universe. But perhaps most importantly, it challenges us to rethink our own biases and assumptions about what is possible. The discovery of K2-141b and its ocean of lava opens up a new realm of possibilities for astrobiology. For decades, we've been looking for life in the most Earth-like environments. But what if life, in all its strange and wonderful forms, doesn't need Earth-like conditions to thrive? K2-141b shows us that, in the universe, there is no one-size-fits-all recipe for habitability. It tells us that life could evolve in conditions we'd never imagined, in places where the environment is far more hostile than we thought possible. As we continue to search the stars, planets like K2-141b could become the goldmine of new discoveries. We've only begun to scratch the surface when it comes to understanding these extreme worlds. Every planet, no matter how seemingly inhospitable, could hold the key to unlocking the deepest mysteries of life itself. The notion of habitable zones may need to be rewritten, with planets like K2-141b leading the way into a new era of exploration. But beyond the scientific implications, there's something deeply humbling about K2-141b. It serves as a reminder of how much we still have to learn. In the grand scope of the cosmos, our understanding is still in its infancy. We've only recently discovered the true diversity of planets in our galaxy, and each one holds its own unique secrets. K2-141b may be just one planet among billions, but it has shown us how much we have left to discover about the conditions that support life, and perhaps even how we define life itself. Consider this. On Earth, life exists in a stunning array of environments, from the searing heat of volcanic vents to the frozen, barren expanses of Antarctica. If life can adapt to those extremes here, who's to say it couldn't do the same on distant planets? In a way, K2-141b represents the ultimate frontier in our search for life, a reminder that we are looking for life where it may be wildly different from what we know. Life, as it turns out, might not be restricted to the conditions of Earth. It could be more resilient, more adaptable, and more mysterious than we ever imagined. It also raises some larger philosophical questions about our place in the universe. For centuries, humans have sought answers to questions about the nature of life beyond our planet. The discovery of planets like K2-141b shows us that we are not just searching for life, we're searching for understanding. We are trying to grasp the true extent of what's out there, in the vast stretches of space, and how we fit into this cosmic tapestry. As we stand at the threshold of this new era of space exploration, we find ourselves asking bigger questions. What if life is more common than we think? What if we're not alone in the universe, but surrounded by forms of life that we can't yet comprehend? Could we one day encounter alien life that challenges everything we know about biology, chemistry, and physics? K2-141b's molten oceans may not be home to life as we know it, but it could hold the secrets to a new understanding of what life could be. As we close the chapter on K2-141b for now, we're left with a sense of awe and wonder. This planet, with its unrelenting lava oceans and hostile atmosphere, serves as a poignant reminder that the universe is vast, mysterious, and full of surprises. Each new discovery, each new planet we uncover, takes us one step closer to understanding the incredible complexity of the cosmos. And just like that, we realize our journey is only just beginning. Every discovery like K2-141b gives us hope and excitement for what comes next in the field of space exploration. Could there be more planets out there similar to K2-141b, waiting for us to explore them? The possibilities are endless, and as we continue to learn, we may unlock answers that could change our understanding of life, the universe, and everything in it. Now, we want to hear from you. What do you think? Could life exist in environments as extreme as K2-141b's molten oceans, or is it beyond the reach of even the hardiest of life forms? Let us know your thoughts in the comments below. And if you enjoyed this journey into the cosmos, make sure to like and share this video with fellow space enthusiasts. Together we can keep exploring the mysteries of the universe.